There's a lot of superstition around the workings of recommendation algorithms amongst users of social media platforms, with some users even believing that Facebook secretly listens to their conversations and gives them recommendations based on that. Needless to say, recommendation algorithms are a pillar of social media and e-commerce experiences users enjoy today. Today, I'll be talking about things to consider when designing recommendation systems, as well as some of the challenges associated with recommendation systems. The three main approaches we will look at today are a collaborative filtering approach. This is a user-user approach where users get recommendations based on what other users like. The content-based filtering approach. This is where users get recommendations based on items that they've interacted with and that they like. And we have a hybrid recommendation system approach, which merges the two. Expanding on collaborative filtering, let's take an e-commerce store, for instance. Recommendations can be made to shoppers based on what other shoppers with similar taste have also liked. We can use a vector space approach to implement this by having a vector for each user, which has attribute values that evolve as a user interacts with content. Then using cosine similarity to find the degree of similarity between different users' preferences. Moving on to content-based filtering. How content-based filtering works is that we build up a user profile from a user's interactions. So purchases, ratings, searches, and clicks. And then we assign specific attributes to items like titles and product features. And then we tailor recommendations by aligning options with user preferences. And we recommend items that a user is likely to appreciate. For example, using a vector space approach, when a user shows interest in a phone with a high resolution camera and 8 gigabytes of RAM, the amount of RAM and camera resolution would be factored into the attributes in the phone's vector. And we can calculate the phone's vectors, the phone's vector of attribute similarity with other items vectors and recommend other phones with high camera resolutions and accessories related to them to the user. The benefits of this is a more personalized user experience, as well as better revenue for companies. Hybrid recommendation systems leverage the pros of having collaborative filtering and content-based filtering. For example, for new users, you might want to recommend content based on what other users that use your site have already liked, because you do not have enough data on these users yet. And then as time goes by and the user builds up their own history, you might want to recommend items based on the user's own preferences. Some of the advantages of using hybrid recommendation systems are enhanced accuracy of recommendations, user personalization, and by extension, user satisfaction. There are some trade-offs between recommendation algorithms. Some recommendation algorithms prioritize personalization, providing precisely tailored suggestions based on individual behavior, while others focus on diversity, offering a variety of options to prevent over-specialization. There's sometimes a trade-off between complex models, which are better at capturing intricate patterns in data, and interpretable models, which make it easy to understand the reasoning behind recommendations. And there's also a trade-off between being able to deal with sparse data and ensuring scalability and efficient performance, even with large data sets. These are some of the challenges associated with recommendation algorithms. The cold start problem. This happens due to not having historical data available about users. One approach to fixing this is setting default values for every user. So that is one solution to the cold start problem. And we can also use a hybrid recommendation system to circumvent this. And then there are scalability challenges, or especially when we have to handle large volumes of users and items, and overfitting and underfitting lastly, ensuring that the model accurately reflects user preferences without being too specific or too general. These are some of the evaluation matrices for recommendation systems. These are all qualitative, as recommendation systems aim to improve a user's experience. So determining how well the system predicts user preferences, measuring the variation in recommendations to ensure that they're not overly similar, because you don't want to show the user the same thing over and over again just because it's similar to itself, and evaluating how unique the recommendations are to the user. These are some of the future trends in recommendation algorithms: further customization based on user behavior and real-time interactions, integrating AI for more accurate predictions, and making the user experience more interactive, engagement through interactive recommendations, recommendation interfaces and experiences.